we begin our journey from our home, Earth. With its nitrogen-oxygen atmosphere, our planet creates a wide range of climates and plays host to a diverse variety of life that thrives on land, in the water, and in the air, ranging from the smallest microbes to behemoth-sized creatures weighing tons. As far as we know, our home, Earth, is the only place that has life in our solar system. As we pull away from our planet, we can look back at a bright blue, mostly watercolored planet with areas of green and brown land evident, and speckled wisps of white clouds hovering above. Moving on, we encounter the brightest object in the night sky, our nearest neighbor, the moon. A gray, cratered, airless world, about 1/4 the size of Earth. It only shows the same side to Earth during its 28-day journey around our home. Yet in its subtle dance with Earth, the moon's delicate pull creates ocean tides and other influences on our weather, as well as stabilizing Earth's own orbit around the sun. With over 190 moons in our solar system, our moon ranks as the 5th largest amongst them. As we move inward on our solar system journey, we encounter a planet that, because of its similar size, is often called Earth's twin, Venus. The second brightest object in our night sky, it is often seen just before sunrise and just after sunset. As we approach, we see a faint yellow-colored planet whose surface is completely obscured by a thick layer of clouds. At one time, Venus was thought perhaps to harbor life like Earth. But if we could peer down through its thick cloud cover over its surface, we would discover otherwise. With a surface temperature of over 900 degrees Fahrenheit, under a crushing toxic atmosphere over 90 times greater than Earth's, we would find it a wholly inhospitable place. As we move away, Venus reveals one final mystery. It is one of 3 planets in our solar system to rotate clockwise. Plunging inward, we come upon a rocky, crater-scarred world not much larger than Earth's moon that speeds around the sun every 88 days. Named for the Romans' messenger of the gods, we encounter Mercury, a gray-colored planet that turns so slowly on its axis that a day is 58 days long, exposing its dayside surface to a scorching over 800 degrees Fahrenheit from the sun, while its night side, the temperature can plummet to nearly minus 300 degrees Fahrenheit. Its trace atmosphere does not distribute the searing heat from the sun, yet surprisingly, in some of its deeply cratered areas at its poles that are shaded from the sun, icy water exists, probably brought by comets or from the planet's interior. Unlike the molten core of Earth, Mercury's solid iron core makes up to 75% of the planet's diameter. Traveling outward from the sun, past the orbits of Mercury, Venus, and Earth, we approach the 4th of the inner terrestrial planets that, when seen from Earth, beams a bright reddish-orange light in the night sky. And because of its blood-red color, the ancient Romans named it for their god of war, Mars. Early astronomers' observation of its most distinctive features thought that its dark lines might be canals that, along with its white polar ice caps, spurred both the scientific and the imaginative prospect with both hope and trepidation that the red planet may be a host to life. But as it turns out, Mars is a cold, desolate desert world covered in a rusty-colored oxide iron-rich soil. As we approach this planet, about half the size of Earth, it is revealed that Mars does have a thin carbon dioxide, nitrogen, and argon atmosphere that features weather phenomena like violent planet-wide dust storms. A closer inspection of its features reveals rocky mountain ranges, valleys, and deep canyons with frozen water ice caps at its poles. Mars has two irregularly shaped moons, Deimos and Phobos, that are considered probably to be captured asteroids. One of the most explored planets in our solar system, it is expected in the not-too-distant future, humans will visit Mars. Our journey takes us away from the four rocky terrestrial inner planets into a space that has a unique place in our solar system. It's a place where resides over 1 million widely scattered ancient rocky rubble orbiting the distant sun, known as the asteroid belt. Larger asteroids, with names like the 300-mile-wide Vesta, or objects that are less than 30 feet across, are mostly irregularly shaped objects. Some asteroids rotate around each other like a small binary system, and in some cases, they even have a moon or moons. The most massive object, at just over 580 miles in diameter, is the spherical-shaped Ceres. It is now classified as a dwarf planet, one of the smallest and the only one located inside the orbit of Neptune. There are 3 types of asteroids: dark ones, consisting mostly of clay silicate mix, then mostly rocky ones with traces of metal, and metallic ones, mostly formed from nickel and iron. If the mass of all the asteroids were collected together, it would form a body somewhat less massive than our own moon. Was the asteroid belt created by some ancient cataclysm, like a small planet violently pulled apart by an overwhelming gravitational force? Or was it a collision between 2 or more planetary bodies? Or was it simply the remnants left over during the formation of our solar system that never coalesced into a planet? We may never solve the mystery surrounding the formation of the asteroid belt. As we travel past the asteroid belt, out over 470 million miles from the Sun, we enter the realm of the gas giants. Unlike the inner terrestrial planets, it is thought these planets may not have any hard surface even at their core. We come upon the 5th planet, the largest in our solar system, named for the king of the Roman gods, Jupiter. It is twice as massive than all the planets combined in our solar system. As we draw closer, visible are Jupiter's distinctive colored stripes and swirls in its atmosphere, including its iconic red spot, a large, raging storm that is larger than the size of Earth. While not as glorious as the ones that surround its neighbor, Saturn, it was recently discovered there are faint rings surrounding the planet. Jupiter has a hydrogen and helium atmosphere with amounts of windy ammonia and water floating within that form the planet's characteristic stripes. With an atmosphere much like the Sun, it has been proposed that Jupiter could have been a star that never ignited, even so suggested in the science fiction work of Arthur C. Clarke. Over 70 moons orbit Jupiter, with the 4 largest moons discovered in the 1600s by Galileo. 25% larger than the planet Mercury is Ganymede, the largest moon in the solar system. It is unique for having its own magnetic field, thought to be created by a liquid iron core and an internal ocean containing more water than on Earth. Next is Jupiter's 2nd largest moon, Callisto, about the size of Mercury Standing as the third largest moon in the solar system, while heavily cratered surface shows no activity, it's just an icy sphere of rock. The volcanically active Io, where due to its close orbit to Jupiter, the planet's immense gravity causes a tidal effect on its solid surface, pulling its crust 300 feet up, covering it with all forms of sulfur. The fourth of the Galilean moons is covered mostly by water ice and is thought to cover a slushy water ice ocean beneath, containing more water than on our own Earth. Europa has intrigued us with the possibility that life may exist underneath its icy crust. Each of these four moons pull and tug on each other, but all share one thing in common. They all show the same face to its master, Jupiter. Jupiter likewise exerts substantial gravitational influence on the other planetary bodies, causing them to alter their orbits, especially back during the formation of the solar system. Moving further outward, almost 880 million miles from the Sun, we encounter the next gas giant, whose pale yellow color is evident as we approach. The second largest planet in our solar system, and the sixth in our solar system, is the most iconic ringed wonder called Saturn. Named for the Roman god of wealth and agriculture, 9 times the diameter of our home planet, it is the furthest planetary object visible to the unaided eye from Earth. Like Jupiter, Saturn is mostly composed of hydrogen and helium gas, and probably also like Jupiter, has a small rocky iron-nickel core surrounded by liquid hydrogen. It is the least dense planet in our solar system. It's less dense than water. Saturn would float in a hypothetical extraterrestrial ocean. Its signature feature are its rings composed of ice and small rocks and dust that are divided into 6 distinct ringlets. While only 30 feet thick, they extend over 175,000 miles from the planet. Saturn has over 80 moons, but 2 are of real significance. Enceladus, the 6th largest of Saturn's moons, and is the whitest object in the solar system. Much like Jupiter's Europa, it's an icy ocean moon. It is unique because it expels geysers of water and carbon monoxide and methane and other gas vapors through its cracks in the icy surface. With apparent internal hydrothermal heating, Enceladus may also harbor the hope for life. Saturn's largest moon, and the second largest in the solar system, is Titan, only slightly smaller than Ganymede. It is exceptional for having a significant nitrogen atmosphere, 50 times the pressure of Earth's atmosphere, creating liquid lakes, seas, and rivers of methane. A thick crust of icy water covers liquid water ocean that may actually hold the potential for life. Leaving Saturn behind, we enter the deep space realm of the outer solar system. At 1.8 billion miles, we approach one of the most interesting planetary anomalies in our solar system, Uranus. This gas giant is tilted 97 degrees to its orbital plane, so it rotates on its side, as well as being the other planet that also rotates clockwise. Also, like Jupiter and Saturn, it sports 10 thin rings. It has a largely featureless surface, except for some wind streaks and 2 dark spots. With its dense, icy fluid atmosphere of hydrogen and helium, with some water ammonia, Uranus gets its blue-green color from methane. 4 times larger than Earth, it is the second less dense planet next to Saturn, and was the first planet discovered using a telescope in 1781. In a break with traditions for naming planetary bodies after ancient mythologies, Uranus's 27 moons are named for Shakespearean and Alexander Pope characters. Oberon and Titania are the two largest of the planet's 5 large moons, are mostly fairly dense rock covered in ice. Many of the smaller moons are either captured asteroids or just rocky ice balls. Traveling almost another billion miles, we come to the virtual identical twin of Uranus, the other gas giant in the outer solar system, Neptune, the last full-size planet on our journey. As we approach, we see a planet that appears bluer than Uranus, yet has a similar tilt of the axis to that of Earth. It is nearly identical in size and atmosphere to its twin, yet with wind speeds up to 120 miles per hour, Neptune is the windiest planet in our solar system. With the dim sunlight at this distance, the sun is seen only as a star-like speck. We can see 14 moons. Most are small, irregularly shaped bodies, some of which are thought to just be captured asteroids. However, Neptune's only large moon is a pale-colored sphere that is the 7th largest in our solar system. Triton is unique in our solar system because it is the only moon that orbits the planet opposite to the planet's rotation. Being so near the Kuiper Belt, home to the other dwarf planets, Triton probably was at one time a dwarf planet that wandered into the planet's gravitational field, capturing it. This retrograde orbit could eventually spell doom for Triton, because every revolution it makes around Neptune, its orbit degrades ever so slightly until eventually it is pulled apart or slowly plunges into the planet below. Triton's surface is exceptionally cold, with a surface temperature minus 400 degrees Fahrenheit, reflecting all the dim sunlight reaching it because of the geysers of liquid nitrogen, methane, and dust that creates a tenuous methane atmosphere that settles onto the surface, freezing into a water, ice, nitrogen crust over its largely rocky metallic core. Neptune's orbit marks the boundary to an area similar to the asteroid belt that stretches out over a further 90 billion miles. The Kuiper Belt is a disk-like area that contains over 2,000 trans-Neptunian objects, and maybe even over hundreds of thousands that are bits of rock, ice, frozen compounds like ammonia and methane. Yet if all of these objects were combined together, it would only make about 10% of the mass of Earth. Some 60 of these objects are larger than 60 miles, including a new classification of objects called dwarf planets. The largest of the dwarf planets is very familiar to us because it was first classified as a full-size planet before inheriting its new classification. Smaller than our own moon, it is located an average of 3.1 billion miles from the Sun and is called Pluto, travels in a greatly inclined orbit, and is also extended so elliptical that at times it crosses inside the orbit of Neptune. It is tilted nearly 60 degrees on its axis, similar to Uranus, plus shares a clockwise rotation. Once thought to be just an icy rock sphere, we now can see mountains of water ice over 9,000 feet high, long valleys and plains of frozen nitrogen coated with a thin coat of methane and other frozen gases over its rocky core. Large craters are visible, and they're indications of some tectonic forces at work. When Pluto's orbit is closer to the Sun, it develops a tenuous atmosphere of nitrogen and methane, changing directly from solid to gas, that returns to coat the surface when it moves further away from the Sun's heat. 5 moons orbit Pluto that are thought to have been formed by collisions of the Kuiper Belt objects that were then captured by its gravity. 4 of these moons are just space rocks, except for Charon, which is half the size of Pluto, and together they may be regarded as a binary planet system. Deeper into the Kuiper Belt are 3 other notable dwarf planets. These include Eris, Haumea, and Makemake. So far, our voyage through the solar system has been where all the planets, moons, and everything revolves around the sun in a generally flat disk-like plane. Yet as we reach the outreaches of the Kuiper Belt, if we pull far away from our solar system, we can observe it is surrounded by a shell of billions of icy objects. Called the Oort cloud, it is so colossal in scope that it is thought to extend nearly a quarter of the way to the nearest star. Within the Oort cloud are the remnants of the formation of our solar system. Objects ranging from mountain-sized matter to snowball-sized bits of rock, dust, and ice. Along with the Kuiper Belt, the Oort cloud is also home to another icy body that makes long journeys inward, comets. There are nearly 4,000 known comets, yet there are likely billions of them that remain undetected. Composed of frozen ice, rock, and dust, as they travel on their highly elongated orbits around the sun, they form a tail of gases that trail millions of miles away from the heating from the sun. This heating also expands the comet's head to the size of a small planet. Comets that are visible from Earth appear over a period of decades or longer because they have wandered billions of miles on their trek through the solar system. Our solar system resides in one of the outer arms of a spiral galaxy called the Milky Way that is host to billions of stars, many that have their own planetary systems. Beyond our own galaxy, it is thought there are 100 billion galaxies in the universe, with our home, Earth, a small speck in the middle of the whole of the cosmos. And it is here we end our journey.